Enqueue in queue. Enqueue is the process of adding an element to the rear of the queue by following FIFO principle. So FIFO is the first in, first out principle, according to which the first element which comes into the queue should always be the element to go out first. So considering this principle, let us say you have a queue and you have many elements in the queue. So it's same as many people standing in the queue. And let us say you want to enqueue. Where will you enqueue? Enqueue means add a new element into the queue. Add a new person to this queue. Where will you add? If this is the front, you will always add a new person at the end of the queue. Anyone who is coming in has to stand at the end of the queue. The same way in data structures, any new element has to be added at the end of the queue. So that is the enqueue operation. So we can do this using arrays as well as linked list. Let us learn about both. We'll start with array implementation and then we'll see the linked list implementation, its time and space complexities. So coming to array implementation, you have an array. Let us say this is your array and it has some elements already in it. Let us say 41, 32, 10, 70. These are the elements. And this is the front of the queue and this is the rear of the queue. So let us say you have more size of the array. So this is the total array that I allocated in order to implement this queue data structure. In this array, I'll always maintain a front pointer and a rear pointer. What is the use of this? In order to do an enqueue, you should always know which is the rear of the queue. That is where to do an enqueue in case you want to add a new element. That is the rear pointer, which always shows the back end of the queue. So here queue is filled till this point 70. So next available position is this block. Whichever be the next available position, that is where your rear pointer will always point to. And what about the front pointer? Your front pointer will always point to the first element in the queue. So here 41 is the first element. Let us learn about enqueue operation, adding a new element into this queue. The first thing you have to check whenever you want to add a new element is whether the queue is having an overflow situation. What is overflow situation? Let us say all these blocks are filled. This is 11. Let us say this is 9, 60, 54. So in this case, what will be the rear? Rear will be pointing outside the array. So array is already full. There is no more element that can be inserted. And your rear pointer will be pointing outside the array. That is the position next at the end of the array. After the end of the array. So if this is the situation, you know there is no option to add anything more because the total space you allocated is the size of this array, which is already exhausted. You don't have any more place to add a new element. So in this case, it is called as queue overflow. Overflow means you're already full in the queue and you can't add any element. In order to check for this, check whether your rear pointer has already crossed the maximum index of the array. If that happens, you call it overflow and enqueue operation cannot be done. So this is the first thing you have to check whenever you have an enqueue operation. So let us say this is not the condition. It is not in overflow situation. Only till 70 it is filled. In this case, you will have rear pointer pointing to the next available block. So how do you insert now? Whenever you want to insert an element, you want to see the rear pointer. Rear pointer will be pointing to the block where you can insert. Let us say I want to insert the value 51. So I'll insert at 51. And then you have to update this rear pointer so that the next insertion, whenever it is to be done, can be done in the next block. So you will update the rear pointer to the next block. So rear is made rear plus 1. It will be updated to the next block. This is what you have to do whenever you want to do an enqueue operation. And one more thing you have to be careful is, we already discussed what about the situation when it is overflow. What if it is empty? What if your queue is empty? Let us say this whole array is there, but there is no element filled at all. So in this case, what will be the situation? Your rear pointer will be pointing to the first block, but your front pointer, it would be pointing to, let us say, some value like -1 or something, which would indicate there is nothing in the this queue. So if this is the situation, then when you are adding the element, yes, you can add the element at the rear pointer. Let us say I want to add 51. So you can add 51 here. But I have to be careful that yes, I'll update the rear pointer, but I also have to update my front pointer to the first element. So this is important. I have to update my front pointer as well in case it is an empty queue. So what are the three things you have to check? First thing, you have to check for overflow. If it is an overflow condition, you have to deal with it. If it is normal condition, you can simply do rear equal to rear plus 1. If it is an empty queue, you have to do rear equal to rear plus 1. That's okay. After that, you also have to update the front pointer. So this is how you deal with Enqueue in case of an array. What is the time complexity here? It's a constant time operation because you simply incremented rear after putting the element in the rear pointer. So time is order of 1. What about space? You didn't use any extra space other than what is already allocated as the array. So it is order of 1 space. This is about array implementation. Let us see about linked list implementation. In case of linked list implementation, your each node will store some value. Let us say 48 is the value in this, and it will also have a pointer pointing to the next node. The next question is, how will this look like in a queue? So a queue will just look like a normal linked list. The only difference is you will have a front pointer and a rear pointer. So this is the head of the linked list. This will be pointing to the next. This will be pointing to the next. And this won't have any next, the last one. So your head pointer, whatever it is pointing, this you will now call as the front of the queue. This is your front. And whatever is your last one, you will always have a pointer which is pointing to the last element. This is called rear. So the only difference with a normal linked list and a linked list that is used for queue implementation is that other than just the front pointer, you will also have a rear pointer which will keep track of the end of the queue. So that whatever operation you have to do at the end, you can directly do using this rear pointer instead of traversing till that point. This is the whole logic. So let us say this is my queue. How do I perform Enqueue? So the first step, the same thing we did in case of array, you have to check for overflow. But is this logical in case of linked list? Linked list is having dynamic memory allocation, which means if I want to add a new element, I can simply dynamically allocate a new node and then add it to this queue. So something that is different from the array implementation here is that you don't have to worry about this overflow condition. You are not having a static allocated memory. Instead, you can dynamically allocate more nodes as well as you want. So because of this, unless your complete memory is exhausted, there is no overflow. So you need not check for that. That is, if you are able to allocate a new node, then it's fine. You won't have any other overflow condition. So the next step, whenever you want to do an Enqueue, let us say these have the elements 10, this is 11, and let us say this is 9. So if you want to do Enqueue, first thing is create a new node, and let us say new element you want to add is 27. So you have to add 27 at the end of the queue, that is rear. So this is the rear pointer pointing to the rear. So in this case, you created a new node. What is the only step that you have to do? You have to link this new node to the rear node. So whatever is your rear pointer pointing to, add the next pointer and insert your new node. Your 27 should be linked by the next pointer of the rear node. Okay. So when you update the current rear, the queue is extended. And what you have to do? You have to set this rear pointer to point to the next one. So now your rear pointer will point to this node. This is the only operation you have to do in order to Enqueue in a queue. And one more thing, if the queue is empty, then what? If it is empty, your front will be null. Your rear will also be null. So what do you have to do? If this is the case, there will be nothing for rear to point to. So rear will be null. Front will also be null. In this case, you have to add the new element, make both front and rear point to the new element. This is how you add a new element in a linked list. Okay, this is your rear pointer, this is your front pointer. So three cases are overflow, which you looked in case of array, here you don't have to look. Here, if you are able to allocate a new node, that means you're good. You don't have to check for any other overflow. And the next step is to change a rear pointer to the next one. And in case it is an empty queue, you have to update both the front and the rear pointer. So this is about enqueue. What is the time complexity? It is a constant time operation. You are simply changing one pointer. It doesn't take much time. It is order of 1, constant operation. Space, again, you're not consuming any extra space other than the space for the new node. So that is order of 1. So time complexity is order of 1, space is also order of 1.